So all the capabilities we just looked at allow you to meet the production challenges of industrial additive manufacturing and can allow you to move rapidly up that AM knowledge acquisition pyramid, regardless of whether you're a designer or a machine operator. You can start to answer some of the complex questions you see here without investing large amounts of resources in experimentation and knowledge acquisition. Just to spend a couple moments going into this, just maybe a level deeper. So what you saw in the video went by pretty quick, but Sonata allows the user to select weightings for optimization between several output goals. So these include the minimum distortion, the minimum support removal, minimum support volume, and minimum build time. And the system uses these weightings, and then it executes up to 100 runs, selecting the best orientation and support structure for the weighted options. So for example, do you want to emphasize a shorter build time, or is it more important to minimize distortion? These are the types of trade-offs you can make easily within Sonata, and the part orientation that Sonata generates can help you mitigate print problems because your part is oriented in an optimal fashion according to your stated goals. Sonata will also automatically generate support structures that help to minimize distortion at the optimized orientation. And of course, these structures also have different options for different goals, such as thermal dissipation or easy removal. And of course, you're going to get some necessary feedback about possible errors like recoder collisions. So in this case, maybe you remove some of the parts on the tray to give the system a little more area to work with for optimizing the part orientation to try and alleviate the problem. So the value of Sonata is its ability to solve, this #1 issue about with quality print generation in an efficient manner without requiring high levels of expertise. You get feedback on distortion, you get supports generated, all according to the various different parameters you've chosen and the needs you have as the user. And tools like Sonata are paramount to improving that return on investment from your additive manufacturing equipment, reducing the number of failures you have, saving you time, money, and material. It's worth noting, however, that Sonata is only one part of the wider Siemens additive manufacturing solution set. So the journeyman and master additive engineers can make effective use of the full suite of Siemens products, including Sonata, but also other additive products like SimCenter 3D additive manufacturing. So Siemens consistently works to ensure that all of our software components are connected end to end and are therefore able to capitalize on the associativity and ease of use that come from a single data model. So build verification is best done in SimCenter, but as we saw earlier, Sonata also produces some of the data needed to verify a build. It's really kind of up to you to decide where your company is on its AM knowledge acquisition journey and to assess whether or not your users will be able to make use of the advanced features and information that come from higher level tools like SimCenter. So SimCenter 3D additive manufacturing is a product that gives a process engineer or a CAD designer feedback on the outcome of an SLM process. So specifically, this is a tool that helps you to avoid high distortion after manufacturing through simulation of global and local overheating. So local in this case is sort of a loose term here because we're not talking about the scale of actual material deposition, but rather the scale of sort of a clump of layers considered as a single mass. That helps us with the efficiency of our simulation algorithm. The challenge here is that producing a part like this that's around, maybe 100 millimeters square, that's going to require approximately 3,000 slices, 10 to 20 hours of production time, 5 million exposure vectors, and a total deposition path something like 25 meters long. So altogether, that's a real large extreme spread of time and length scales where a lot of things can go wrong during a print. So let's say that you're at the point in your process where your orientation is fixed for one reason or another. Say that you want a specific surface finish, or you need to pack things tightly into the build tray to attain your desired return on investment or something like that. In cases like these where the part orientation is fixed or reduced, or the range of motion is reduced, a tool like Sonata may not be suitable for use because Sonata needs degrees of freedom to optimize part orientation. This is one case where tools like SimCenter 3D AM come into play. So using SimCenter, you can simulate the build process of the entire tray, and then from that simulation, the system can generate compensated geometry that can be used to mitigate distortions, local overheating, shrink line. So again, it's another tool in your arsenal that can move you up that knowledge acquisition pyramid where you achieve a lower failure rate and a higher return on investment. We look at a few details for how this works. SimCenter 3D AM uses a mechanical model for the simulation, and we use these bridge parts that you see here to calculate the simulation to a given machine and material. So if you add a new machine or a new material to your workflow, you simply run the calibration again, and that delivers a new simulation model for that new process or material. So this calibration process is what allows the system to generate really accurate results through a simulation tailored specifically to your situation. It's also what allows SimCenter 3D AM to grow as your business grows and as you begin to support new additive processes and materials. So you're not locked in, like we talked earlier, to only supporting a certain machine and a certain material to have your expertise. This helps get past that problem. So the result here is the ability to analyze the temperature buildup within the build tray, either with or without powder. And it's also worth noting that SimCenter 3D can also accommodate multi-laser systems because the effects of the scan strategy included in the simulation.